Welcome engineers and design professional. In today's lecture we will be discussing about steel structure and more specific about staggered holes. That what is staggered holes, what will be the net area in case of staggered holes, and what will be the failure path in staggered holes if we provide holes in a staggered pattern. So due to some limitation we will provide holes in this pattern rather than providing the holes in a single row or in a parallel pattern. So staggered fastener, if the holes are provided in a single row, then this connection will yield more area, net area, maximize net area if the all the bolts are connected in a single line. This is the better option to provide the holes in a stagger in a single line. So due to some limitation, we cannot provide the holes in a single row. We will provide the holes in a parallel pattern or in a staggered pattern. So the reason was that sometimes there might be a limit on the dimension. We cannot provide the holes in a single row or in a parallel pattern. We will provide the holes in a staggered pattern to minimize the area if the fastener are in a staggered pattern. If we provide the holes in a staggered pattern, the net area will be minimized. If the net area is minimized, this means that the member cannot take more load for which it was designed. This is the main reason. So before failure, it cannot take the load which was for which it was designed. So if the net area is more, this means that the member can bear more load before failure. If the net area is less, this means that the member cannot bear more load before failure. This is the main concept behind the net area, maximize net area, minimize net area. So remember this. Due to some space limitation and the geometry of the element, we cannot provide the holes in a single row, then we will provide the holes in a staggered pattern. Remember this. So this is very important to understand the whole concept of providing holes in a staggered or in a parallel pattern rather than in a single line. So there are two limits on the limit and dimension and geometry of the connection. We cannot provide holes in a single or in a parallel pattern. We will provide holes in a staggered pattern. Due to staggered, there may be a failure path will be different from the parallel or in a staggered types in a staggered holes. There will be a difference in the failure path. Remember this. And basic terms in a staggered pattern are the staggered length and the gauge length and the failure path. And this one of the one of the engineer provided that when using the staggered holes, we will be using another terms, another factor, which is made from this two lengths, S and G. What is S? This is the center to the center distance between two holes. If the this distance is parallel to the applied force, direction is applied force. If the direction of the applied force is this, then center to center distance between these holes is termed as staggered length. Remember this. And if the force is this, the perpendicular distance between perpendicular center to center distance between two holes is termed as gauge length. This two dimensional is very important. It depends on the direction of the force, applied force, which the tensile force is applied in which direction. Here the tension force is applied in this direction, so this will be the S and this will be G. If the force in some cases applied in this direction, then this will be the G and S will be this. Remember this. It will convert, it will transform. So one of the engineer Cochrane in 1922 proposed that when deducting the area, we will be using a reduced diameter if we provide the holes in a staggered pattern. So we will be reducing a diameter by this factor. So the diameter of the bolts minus the staggered square divided by 4 times of the gauge length. So we'll be using this reduced diameter in calculation of net width. Remember this. So what will be the net width of this hole of this element if the holes are in a staggered pattern? So net width will be the gross width minus summation of the reduced diameter. So here you can see that instead of d dash we will put this as we studied in last slide, that d dash is equal to d minus s square divided by 4g. And after applying the summation with each term, we will get this summation d plus summation s square divided by 4g. What is summation here? The number of bolts. It represents the number of bolts. Here for this example, how many bolts or holes occur here in failure path? 2. So we'll be instead of summation we'll be using 2 times of the diameter of bolts plus in this summation s square divided by 4g. In this summation, this represents the number of inclined lines. Here is only one inclined line, so we'll be in this summation we'll be using only one number. So the net width will be the gross width minus summation of diameter plus summation of s square divided by 4g. You know that what will be the summation of d and what will be the summation of s square divided by 4g. So net width will be equal to this. So what will be the net area? In case of staggered hole, the net area will be this, that the net width multiplied by the thickness. What will be the net width? It is the value which we discussed in last slide. And now in calculation, in actually the design of tension member, we need effective area. So this effective area is equal to this net area multiplied by shear leg reduction factor. As we discuss, we know about the shear leg reduction factor. There are 5 categories for finding the value of shear leg reduction factor. The number 1 is the by equation method. Number 2 is for plate. Number 3 for the hollow structural steel. Number 4 and 5th are the for the alternative values for single and double angle and for other shapes. So net area for this will be changed as different from the parallel pattern. The net area of the staggered pattern and the parallel pattern are different. Remember this. So this was the today's topic. I hope you got the concept. In next lecture we will be solving a numerical regarding this net area of the staggered pattern, etc. So thanks to everyone. I hope you got it.